This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the May-June 2023 Cambridge 9709 paper 3 variant 1, a question on vectors. And this question here, we have been told that relative to the origin O, the points A, B, and C have position vectors given by O to A, 2, 1, 3, O to B, 4, 3, 2, and O to C, 3, -2, -4. The quadrilateral ABC is a parallelogram. Okay, find the position vector of D. Okay, so we got to find the position vector of D, given that this ABCD is a parallelogram. So a parallelogram is a special quadrilateral which has properties which are very important in vectors, and those are that the opposite sides are equal in length and parallel to each other, which helps us a lot with vectors. So as we have a three-dimensional vector system here, to actually draw or to make a sketch of this in an accurate way is basically not very easy at all. It's kind of impossible. So I'm just going to draw any old parallelogram, and I'm just going to call the corners, as A, B, C, and D in a particular way, which I'll explain. So I'm going to draw a parallelogram. Okay, so this is the parallelogram I'm drawing. Let me make it so that it fits with these lines better. Okay, so here's a parallelogram. I'm going to call this point O. I can just choose a random point, call it O, and I'm going to draw lines from O to each of those 4 corners. So from O to this corner, and from O to that corner, O to this corner, and O to that corner. Okay, now parallelograms, if it's a parallelogram A, B, C, D, so we're going to start with A, and then we put B, and C, and D. Normally you should go clockwise when you're labeling, a polygon, right? You should go clockwise, and it should be in order. Like I shouldn't put A, B, D, C, for example. It's A, B, C, D, A, B, C, D, in the same order that these come, right? So that's how you should label your diagram, okay? So the quadrilateral ABCD is a parallelogram. So now, we know the vector O to A is 2, 1, 3. I like column vectors, and they gave us column vectors, that's good. We know the vector O to B is 4, 3, 2. We know the vector O to C is 3, -2, and -4. Let me just write that a bit neater. Three, -2, -4. Right? I know that this side is parallel to this side and the same length, and this side is parallel to this side and the same length. These two lengths are the same, and these two lengths are the same. Okay? So we know the opposite sides are parallel and equal in length. So we want to find the position vector of D. When it says the position vector of D, what it means is the vector from O to D. That's what the position vector of D means. So we want to find the vector that takes us from O to D. Now we know the vector from O to A. Okay, we know the vector from O to A. Okay, and if I add to it the vector A to D, I'll get the answer. Okay, so how do we do that? How do we know what A to D is if we don't know what D is yet? Well, this is how we do it. So we know O to D would be given by O to A plus A to D. We could also do it O to C plus C to D. So that would also work. You can say or O to D is equal to O to C plus C to D. Both of them should give us the same answer, and I'll show you how it works for both of them. But how do we find what A to D is? Okay, well, A to D and B to C are opposite sides of the parallelogram. So they are equal in length and they are parallel. So basically, A to D is the same vector exactly as B to C. How to get from A to D will be exactly the same vector as how to get from B to C because they are parallel and equal in length. Okay, so I can see what B to C is. Okay, we can work out how to find B to C. So I can say O to D is equal to O to A plus B to C. So how do I work out what B to C is? B to C. Now B to C is the same as going from B to O plus O to C, which is the same as O to C minus O to B. Okay, so if I want to go from B to C, I go B to O, which is minus OB plus OC. Minus OB plus OC, which is the same as saying OC minus OB. Okay, when you see something like this, in terms of going back to the origin, this is how it always works. It's always O to the second one minus O to the first one. All right, and you can kind of see why. So we can now put in our vectors. We can say O to A, we know is 2, 1, 3. So we have 2, 1, 3. Plus, I'm going to have O to C, which is, let me take it from here. It's a bit more neater. 3, negative 2, negative 4. 3, negative 2, negative 4, minus O to B, which is 4, 3, 2. And that will give us our answer. Okay, this here is the vector B to C. Okay, and this is O to A. So we're going to have 2 plus 3, which is 5, minus 4, which is 1. 1 minus 2, which is negative 1. Negative 1 minus 3 is negative 4. And we have 3 minus 4 and minus 2. That's going to be negative 1 minus, that's minus 3. So you have 1, negative 4, negative 3. So we can say O to D, the position vector of D, is equal to 1, negative 4, negative 3. And there's the answer. Okay, position vector of D. Now, the question gave us the vectors in column vector form. So we should really give the answer also in column vector form. Okay, if you put it as I minus 4j minus 3k, that's also okay. But I would prefer to give it in this form because the question was given in that same column vector form. I personally prefer column vector form. So there's the answer to part A. I said I'd also show you how to do it using this other method, and it should give us the same answer. We can do O to C plus C to D. Okay, and we can see from here that C to D, if I want to go from C to D, it's the same as going from C to O. Same kind of thinking, C to O plus O to D. So we're basically going to have OD minus OC. Okay, OD minus OC, and we can work out what that is here. OD, as we can see from here, is, what am I doing? 1 second. I did something silly there. Okay. What I'm saying is we can do O to D equals O to A plus A to D. Okay. So it's O to A plus A to D. And we can also say O to D is equal to O to C plus C to D. Now, what I meant to say was C to D is the same vector as B to A. Sorry about that. It's the same vector as B to A. So C to D is the same vector as B to A, right? So if I find what B to A is, it's the same as C to D. So B to A is going to be basically OA minus OB. Okay, that's B to A. Because you're going to go minus OB plus OA. If I want to go from B to A, minus OB plus OA, so it's OA minus OB. Okay, and OA is the vector 2, 1, 3. And OB is the vector 4, 3, 2. So this gives us the vector 2 minus 4, which is minus 2. 1 minus 3, which is minus 2 again. Okay, and 3 minus 2, which is 1. So that's the vector from B to A. Okay, so we can say here that O to D is equal to O to C, okay, which we know is 3 negative 2, negative 4, 3 negative 2 minus 4, minus, or plus, sorry, C to D, which is the same as B to A, which is negative 2, negative 2, 1. So negative 2, and 1. And when you add them together, you have 3 plus minus 2, which is 1, minus 2 plus minus 2, which is minus 4, and minus 4 plus 1, which is minus 3. You see, we get the same answer exactly. Okay, so it doesn't matter which way you do it, you get the same answer. You can go from O to A and then A to D, and A to D is the same as B to C, or you can go from O to C and then from C to D, and B to A is the same as C to D, and you get your answer. So there's the answer to part A. Okay, now for part B, the question is telling us the angle between BA and BC is theta. Find the exact value of cosine theta. So I'm going to bring the diagram across so we can have a look at it. Okay, so now it says the angle between BA and BC. So this angle here, they're calling this angle theta. It says find the exact value of cosine theta. Okay, so find the exact value of cosine theta. So we can say basically that one of the formulae that we should know, and I think it's in the formula sheet. Let me just confirm that. Okay, so here we have an extract from the formula sheet, and what we're interested in from this formula sheet is this particular part. A dot B is equal to magnitude of A times magnitude of B times cosine of theta. So A dot B equals the magnitude of A times the magnitude of B times the cosine of theta. This tells you the angle between two vectors when they are placed tail to tail. Okay? The angle between BA and BC. BA and BC. So when they're placed tail to tail. So it's like BA this way, BC this way. That's the angle between them when they're placed tail to tail. So how do you find the dot product? So let's call A, for example, vector BA. Okay, A is vector from B to A, which we already found in the last question. And B, we call it the vector from B to C, which we already found also in the last question, all right, because we did it in both ways. So vector A was B to A, which was negative 2, negative 2, 1. Okay, so this was negative 2, negative 2, and 1. And B to C, I kind of find it in a, not in a direct way. I did it as part of the big calculation. Let's do it now. B to C, as we know, it's going to be O to C minus O to B, which is going to be this minus this. So it's going to be 3 minus 4, which is negative 1, minus 2 minus 3, which is negative 5, and negative 4 minus 2, which is negative 6. Okay, so that's B to C, negative 1, negative 5, negative 6. Okay, let's just confirm that that's how we would have found D. We would have had 2, plus that would have been a 1, 1, minus 5, that would be a minus 4, and 3 minus 6, yeah, it would give us the same answer. Good. Okay, so that's B to C. So now we need to find, oops, I've run out of space here. Okay, it's because of the diagram. Let me just take this diagram and do something to it. Hold on. I'll do something else to it. Give me a second. Okay. So I'm just making this a bit smaller so I can still see what's going on, and I can get rid of this now. Okay, so now let's move this up there so we have more space. Okay, so we know what A and B are, so we need to find the magnitude of A and we need to find the magnitude of B. Now the magnitude of A is basically the square root of these numbers squared and added together. We don't have to worry about the signs because they're going to get squared, so it'll become positive anyway. And for B, it's going to be the square root of 1 squared plus 5 squared plus 6 squared. So this gives us a square root of 4 plus 4, which is 8 plus 1, which is 9. So that's going to give us 3. This is going to give you 1 plus 25 plus 36. Okay, so that's 26 plus 36. That's 62. Is that right? Let's just make sure. You have 1 squared plus 5 squared plus 6 squared. 62. Square root of 62. Leave it like that. And we've got to find A dot B, which is called the dot product of these two vectors. To find the dot product of the two vectors, you just basically multiply the I, J, and K terms together. So minus 1, minus 5, minus 6. You just multiply them together and add the result. So minus 2 times minus 1 is positive 2, plus minus 2 times minus 5 is 10, and 1 times minus 6 is minus 6. So you get 12 minus 6, which is 6. So therefore we can say cosine of theta is equal to the dot product, which is 6 over, and then you have the product of the two magnitudes, which is 3 times the square root of 62. So therefore theta is equal to, we want the exact value. So this is the exact value, but we want to have it in a form which is, like rationalized. So first of all, 62. Is there any perfect square in 62? Okay, 62 can be expressed as 21 times 2, no, 31 times 2, sorry. And then you're going to have, I don't think there's a perfect square in here, is it? We can check. We can just put root 62 in our calculator. No, there's nothing. You can't break it down. So if you multiply the top by root 62 and the bottom by root 62, we can rationalize the denominator. So you have 6 root 62 over 3 times 62. Okay, now 3 times 62. Okay, first of all, in fact, what we can do before even that, let's just make it easier for ourselves. Why make life difficult? We can cancel out this with this. So we end up with 2 times root 62 over 62, which gives you, this cancels with this, that gives you 31. So you're left with root 62 over 31. So that's the exact value of cosine theta. Okay, so cosine theta equals root 62 over 31. And there's your answer to part B of this question. Now, if we had left our answer in this form, 2 over root 62, that would have been acceptable. But it's always best, I think, to write things in their simplest form. Okay? And even if you put this in your calculator, for example, it would give you, if you put, for example, 6 over 3 times the square root of 62, it will give it to you in simplified third form anyway, right? So it's always best to write things in simplified third form. So there's the answer to part C. So then it says, hence find the area of ABCD, giving your answer in the form P root Q, where P and Q are integers. Now here's something where you have to be a bit careful. So when you have to find the area of a parallelogram, so I'm going to draw another parallelogram. Okay, you want to find the area of a parallelogram, right? So we have ABCD, ABCD. Okay, I know this angle. I don't know what the angle is, but I know the cosine of this angle. Okay, now you need to be careful about certain things here now. We want to give our answer in exact form, P root Q. So I know that the cosine of theta is equal to root 62 over 31. Okay, that's the cosine of theta. Okay. Which we can also write as, for example, 2 over root 62. Okay, they're both the same as we saw from here. Now, I know that the vector from A to B, we already know its magnitude. The vector A to B its magnitude was 3. Okay, and the magnitude of the vector from B to C was root 62. Okay, don't worry about how the lengths look here. Okay, that's not important. In fact, if we want to draw it properly, the parallelogram would look like this now. Now we have some of the lengths on it. We can kind of work out that the parallelogram will have this type of shape. Okay, where this side is actually, A is here, and D is here, and C is here. That's root 62, and that's 3, and here is theta. Okay, so it's like this side is actually shorter than that side. Root 62 is more than 3, of course. Okay, so that's how it actually looks, but it doesn't matter when we do the diagram, for the vectors, it really doesn't matter. Okay, but that's how we know it looks now. So how do we find the area of a parallelogram? Well, one of the formulae that is going to be very useful for us is AB sine theta. The area is the length of two sides multiplied times the sine of the angle between them. Now, we want to give our answers in exact form. If I try to find the angle theta using this, I'm going to get a problem here. If I do shift cosine of this angle, okay, it's going to give me an angle in decimals. And if I find the sine of that angle, it's going to give me something which is going to be in decimal form. And I want it in exact form. Okay, I want it in exact form. You could try to do the sine of the inverse cosine of 2 over root 62 or root 62 over 1. Oops. Of root 62 over 31. Again, it gives you a decimal, right? So it's not going to help us, all right? So you trying to define the angle here won't help us give the answer in exact form. So this is where you should be confident with this, where we can take this triangle. You can imagine we have a triangle. Imagine this is theta. Cosine of theta is root 62 over 31. Okay, you can write it like this, root 62. And to make the numbers a bit easier, we can write it as 2 over root 62, gives the same ratio. 2 over root 62, adjacent over hypotenuse. So we can find what this opposite side is. Okay, the opposite side will be the square root of 62 squared, which is going to be 62 minus 4. So it'll be the square root of 62 minus 4, which is the square root of 58. Okay, so we can say the sine of theta is root 58 over root 62. Okay, so therefore the area is going to be 3 times root 62. Okay, A times B times the sine of theta, which is root 58 over root 62. The root 62's cancel. Now we're going to find what root 58 is. We can do this in our calculator to see if it's going to give us a breakdown. No, it's not. So the answer is 3 times root 58. There's no perfect square in there. So the area we're looking for is 3 times root 58. Okay, that's in the form P root Q, where P and Q are both integers. So doing this is something that's important for us to know how to deal with this type of question in order to give our answers in exact form. Okay, so there's the answer to this question. Question number 6 from the June 2023 P3 paper. Okay, so other questions from this particular paper can be found in the playlist that will appear on the top right of the screen at the end of the video. Other questions from the topic of vectors in P3, you'll find them in the playlist on the bottom right of the screen. I'll also add my playlist for vectors from P4 of Edexcel, which have very similar type of questions, which will benefit you if you want to look at others, other questions that you might not have. You want to get more practice. You can subscribe to my channel by clicking on this link at the top. Thank you for watching and see you soon.